In today's video, we're going to talk about reading an input. Let's begin. So in this lesson, we are going to go through how to read a pin, serial monitor, pull up resistor, and conditional statements. So in previous lesson, we talked about using the Arduino. We program it to set the pin state. Okay, write the state to high, which is to switch it on, and or switch it off. So we learn how to write the state of the LED, okay, digitally. So in this lesson, what we really want to do is we want to read the pin instead. So instead of writing, we're reading what's the state of the pins. Is it high or is it low? So that's what we are going to do. Before we go into that, how can the computer talk to us? How can the microcontroller talk to us? So we need to use the serial monitor in order to read the input. So let us do this. So I'm going to create a new circuit. And I'm going to take out the Arduino. Then I'm going to open up code. So I'm going to clear out this portion, and I'm going to put in, so under output, so we are actually output. So we are going to later read an input, and then after we are going to output, but we are going to output to the serial monitor. So the serial monitor is how we can actually talk to the microcontroller. From the microcontroller, it can talk to us. Okay, so when I put in this print to serial monitor hello world with new line, then later what we will do is that it will actually print out to here. So we can maybe take a look at this first. So there's nothing here, so we just start the simulation, and it will actually just start to print out hello world in the serial monitor. So I'm going to stop this and clear out, then explain the code. So what it does is that when you put in one block like this, what Tinkercad will do is that it will declare for you serial.begin 9600. What does it actually mean is that if you look at the next one, so 9600 is not a random number. It is actually talking about the transfer of the information at 9600 bits per second. So it's 9600 baud. So serial.begin, we are saying that we are listening at 9600 bits per second. So it begins to listen at serial.begin. It will begin transmitting at 9600 baud. Okay, so later when we use the serial module, we need to actually put in the check that there is. So let's say we look at this Arduino tools serial monitor. So there will be this. So we need to set the right bits per second, the frequency. So there are many, but the default is 9600. We are going to stick to that. So next. So serial.begin 9600. Then in the loop there is this serial.print line. So in the serial, we are going to print with new line hello world. Okay, that's what it's trying to say. The delay is because of the simulation. So later we will just delete this. So I'm going to just transfer these to the Arduino here, or we can I'll just type it out here. So serial. Okay, when you type in any keywords, they will actually be colored, so you know that you type in the right thing. Serial.begin. Okay, see that the begin is also colored. Serial.begin 9600. Okay, so you are typing in the function, so it will actually color it. So serial.begin 9600, we are going to say here serial.print line print ln. Okay, let's say hello YouTube. Okay, semicolon. So let's run this. So upload. So when I upload, I need to set. So I'm going to set this to today's date, July 8. Save. So it's done uploading serial monitor, and you can see that it's printing out hello YouTube. Now we are going to stop this. We are going to, oops, there's no way to actually really stop it. We need to just flash it again, because there's no shutdown button for the if there's a shutdown button for the simulator, there's no shutdown for the hardware. Okay, so what I'm going to do here is, if you don't want it to print into a new line, you can actually print in without a new line. So if you don't want a new line, you will put serial.print, and for here, if you change it to without new line, you will see that it will change the code to serial.print. So what we are going to do is, I'm going to just flash this. Okay, so now it's printing without a new line, so I can clear output. Okay, so that's how it will look. So next, we are going to go on. So this is how it can talk back to us. Okay, he can send back to us information that we will want. So next one is a pull up resistor. So in this example, you can see that there is this resistor. This resistor is a 10k ohm. So what it does is that 5 volt will go through here, it will go through this resistor, and then we go to 4, and then we want to read what value is in 4. So a pull up resistor ensure that it is always high, okay, read in a high state. So when you press the button, it will drop to low. So that is the purpose of the pull up resistor. You pull up the value, and when you press it down, it connects this connection. So the power will go from here down and go back to ground. If not, it will just go up here and then go here. So it will read it 4 as high. So we are going to do this to show you. So I'm going to hide this, and I'm going to just add in the breadboard. Okay, then this will be to 5 volt. Then we have one to ground. Okay, so this is done. Then what we need to do is we need to put in the resistor. Again, this got to be 10 kilo ohm. So 10k ohm, it got to be heavy enough so that we don't get a short circuit. So this is 10k ohm. Then what we're going to do is we're going to put in the button. Okay, then I'm going to connect here to here. Okay, so that it will go down. Now next, there will be another cable. You can either connect it here, or you can connect it here. So I'm just going to make some changes here. So I'm going to connect this to pin 8. Okay, orange. So you can either connect here, or you can connect here, no problem. Okay, so we're going to plug it here. Then what we are going to do is, in the code, okay, we are going to start to put in input. So we are going to read digital pin. Okay, just now I connect to pin 8, so I'm going to put read digital pin 8 with new line. Okay, and once it reads, whatever is in digital pin 8 will be printed into a serial monitor. So let's look at the code. So when it's an input, just like output, you need to declare the pin mode. So for this example, pin mode 8 input, this is done automatically by Tinkercad for you. So but if you are typing it out, you need to remember to do this. Then serial.print line, instead of printing hello world, we are printing digital read pin 8. That's it. Okay, so next we are going to start simulation. Before I do this, I'm going to just drag this over to here. Yes, and start simulation. Okay, so now it is reflecting the reading as 1. 1 means it's high. Okay, so high or low. So digital is high or low, 1 or 0, on or off. So this is 1 is high and is on. So there's power. So if you press on the button, it drops down to 0. So that is how we can actually read the button. So this is O, 0. So this is low. So when you let go of it, then it goes back to 1. So that is how we can read the button. Next. So I'm going to do this on the Arduino. Okay, we're going to do this on the Arduino, and then we're going to show you. So next. So the resistor inside your packs, there are 2. You are not going to use the double orange resistor, which is 330. Instead, you are going to use the 10 kilo ohm resistor. So take out, make sure that it is 10 kilo ohm, which is 1. Okay. Okay, so make sure it's this. Okay, it looks let me just switch on the light. Okay, so this is how it looks like. It is actually brown, red, black, black, brown. So you should be using this. So let's continue. Okay, for this ground, again, just going to do it just like the circuit then. Okay. Okay, then I'm going to connect pin 8 to here. So this is one way you can actually do this. So you can actually see, okay, so now it is connected properly. What we need to do is just to read. Just now it's connected. You can see that actually when I press the button, pin 8 will actually drop to 0. So you can see actually the light that will switch off when I press. Okay, you can see the built-in LED on pin 8. Even before I just do the reading. So I'm going to just type out the code, okay, or you can just copy also. So I'm going to just type it out here. So pin mode 8 input, okay, all caps. You see the color change. Okay, pin mode 8 input. Then after that we will say here digital read 8. Okay, so whatever is 8 will be read and will be printed into serial. I'm going to just push this in now. Okay, done. And go to serial monitor. So is printing. Okay, so this is okay, I want a new line. So print ln. I'm going to just flash this now. Okay, so it's printing already. So next thing I'm going to do is I'm just going to clear output. Okay, good. So next, so now is one. If I press down, you can see that it is now 0. When I let go, is 1. So the reading works. Okay, we are able to actually read the value of the button. Okay, so this is how digital reading is done. So you can connect it like this, just like in the circuit. So next we are going to go on. So that is pull up resistor. Okay, so that is how it actually works. Later we can look at there is another example, which is the pull down resistor. So if you look at this, the pull down resistor is done slightly differently. Okay, so it is you alternate. So instead of positive is put at negative, and then this one is connected positive. So this is the pull down resistor. You actually just need to learn one method, but you can, if you want to, you can actually also do this. So what it does is that when the button is not pressed, it is low, but when you press the button, it will become high. Okay, it will be read as high. So that is what this is for. Okay, so we can also sort this out and try it out. So maybe I'll just do it here. So I'm going to just plug it to positive, and this one I'm going to plug it to negative. Okay, so same thing, but now I already do the swapping already. So as you can see, I already swap the positive and the negative. Okay, I already swap. Now it's 0 when I press. So this is pull down resistor. When I press, it goes to 1. When I let go, it's 0. So this is pull down resistor. So I'm going to swap back to the normal way of doing it. So I'm going to just pull it out and shift it. Okay, so now it's back to 1, and then when I press, it goes to 0. So pull up, pull down resistor. So that is the two ways of doing it. So if you want to, you can go and Google about it. So we just going to stick to pull up resistor for now. Now next, you want to do more things than this, than just reading the button state. Then we need to learn conditional statement. So what is conditional statement? Is just asking a question. Okay, so you ask a question whether is it example is if it is a rainy day. So it's either a rainy day or is not a rainy day. Okay, so if for this example, if it's a rainy day, pick up an umbrella. Otherwise, not a rainy day, you wear a cap. But whether you wear a cap or you bring an umbrella, you go to school. Okay, so that is an example of a conditional statement. So you ask a question, if it is something, you do a series of things, or one thing. Okay, you can do a series of things. So for our another example is, if button is pressed, we want to light up the LED. Otherwise, we switch off the LED. So depending on how you do up the pull up or pull down resistor, you know whether the button is pressed by high or low. Then you can light up the LED, which is high. Then otherwise, you switch off the LED. So so this is an example. So if the button is not pressed because it's high, this is a pull up resistor example. If digital pin 8 is high, we switch off the LED, or else we switch on the LED. So this is, in this example, we use this as a LED switch. We are going to do this now. So here we are going to just plug in the LED, and we're going to put in a resistor. So this resistor got to be 330 ohm. So 330 ohm. Okay, and we have another cable to, maybe let's say we connect this to pin 7. Yeah, I'm going to change the color to maybe green. Okay, next. So you may want to adjust the cables. Okay, jumper wire. So done. So like this, 7 provides the power, and then it goes down this resistor and it goes back. So what we are going to do here is we are going to, so I'm going to go back to blocks. So here we are going to say that so we are not going to do this anymore. We are not going to read the serial monitor. What I want to do is maybe control. So there is some blocks here that you can actually use. You can use the if else. Okay, if else. So this is if it's read as high, then you switch off the LED, or else you switch on the LED. This is just if it's high, you do something. That's it. But there is no else. So you choose your block, choose the right block. Yeah, depending on what you want to do. So I'm gonna just plug in this. So take note of the shape difference. So this is actually to do the smaller, smaller or equal to, equal, not equal, larger, larger or equal to. So I'm gonna just put equal. If digital pin A is equal to, you can put it, leave it as 1 0, just like it, or you can put a high or low here. Okay, that doesn't really affect. So I'm going to say that if read digital pin A is equal to high, then what we are going to do is we're going to output set pin, this is pin 7 to low, or else we are going to set pin 7 to high. Okay, let's start simulation. So press, it will light up the LED. When I let go, it switch off. When I press, it lights up the LED. Let go, it switch off. Okay, so this is what you can do to program this portion. So I'm going to just quickly transfer this to the, so you can look at blocks plus text, and then you can copy and paste over. Okay, so I'm going to just go back to here. So here I think I don't need to read this anymore. I'm going to delete away. So okay, so next, so now we need to declare a pin 7, pin mode 7 output. Maybe I should I'll do the connection first. So I'm going to pull out. Okay, then I'm going to plug in my LED. Okay, so this LED, I'm going to plug it here, and resistor. So I must make sure that the legs of the LED positive, negative, make sure you put them correctly. So the longer leg is positive and shorter leg is negative. So plug this in, and I'm going to just plug these to negative. Okay, and I'm going to plug in another wire, this wire to pin 7. Okay, done. So all these are quite simple. I'm going to plug in the power again. So next, what we are going to do is we are going to say pin mode 7 output. Okay, you must declare output. Okay, so you can actually just copy from here. I think I'll just copy from here, then easier that way. So I'm going to copy this, and I'm going to paste this here. So this is the if else statement that just now we wrote. So if digital pin A is equivalent to high, okay, we will digital write 7 as low, or else we will digital write 7 as high. So if, so this one, if button is not pressed, okay, so we will switch off LED, or else we're going to switch on LED. Done. So I'm going to just flash this in now. Okay, done. So when I press this button, it lights up the LED. When I let go, it switches off the LED. Okay, next. Okay, what we are going to do is we are going to put in another LED. So copy, paste. This time around, I'm going to change the color to blue. Okay, so this is where we stopped for the previous lesson. So what we are going to do is I'm going to connect this 7 6. Okay, 7 6 turquoise. Okay, and next, so 7 6. Okay, so what we're going to do is that if it reads it as high, we will switch off pin 7 and 6. So I'm going to just put here 6 as low. Okay, so if it's not, the button isn't pressed, both are low. If it's pressed, then what we are going to do is we are going to set pin 6 to low. Okay, then after that we will delay. Okay, so we will do the blinking. Okay, we will do the blinking here. So right click, duplicate. Okay, so low, high. Okay, done. So next we going to just so I'm going to just go to blocks, start simulation. Okay, so this code here, when I press the button, it will start to do the alternating. Okay, so previous lesson we did the alternating of the LED, but this lesson we add in input. So when your button is pressed, you are pressing and holding it, it will do this alternating. When I let go, it will actually switch off the LED. Next, what we are going to do is we are going to plug in the other LED. Then we are going to do the same for hardware. Okay, I guess I'm going to use green color. So I'm going to plug this in here. Next. Okay. And then I'm going to plug in this. To here. Okay, done. We'll plug in the power. So next we're going to write for this portion here. So we are going to just say that I'm going to copy this. Okay, so digital write 6 low. Okay, then else we will say 7 high, then 7 high, 6 low, and delay. Maybe for this example, we will delay for 500 milliseconds instead. Okay, then we were going to copy this. Okay, and paste this, alternate this, low, high. Okay, that's it. So I'm going to just so this part I'm going to delete away there. Okay, so I'm going to flash this in. Okay, done. So when I press the button now, okay, oops, I know why, because we forgot to declare the output. So pin mode 6 output. Okay, so next, let's push in. Okay, done. Okay, so now it's working. Okay, so very important that we remember to declare the output. If it doesn't work, then you just need to troubleshoot lah. So this is done. You can actually just instead of typing out, if you are not confident, okay, you can actually go to blocks plus text, just copy and paste this code in. So that is for the LED switch. We combine previous lesson what we learned and this lesson. Then next thing is if you want to, you can do more things by catching repetition. This is an example, catching repetition. You put in so you can do things like if you put in this if else statement, and then you put in a variable to remember the previous state. So when you do this, it will not spam the 1 and 0. So example is actually here. So you can actually click on this, and I'm going to show you. So it is actually this Arduino. So I'm going to just open up the code, then make sure you are on first Arduino. So from here, this drop down, you choose first one Arduino. So this is Arduino 1. So we are going to try this out. So this serial monitor, and I'm going to start simulation. So what it does is that when I press down once, it will say press. When I let go, it will say release. When I press it down again, it say press. It doesn't spam. Okay, it just tell you the state. You are pressing it. You're still pressing it. There's no change in state. When I let go, it says release. So how is this actually done? What is the difference? So from here, we actually remember, okay, so if it's low, that means you press it, you are pressing it now, and the button is equal to 0. So it is saying that previous state is not pressed. Okay, you didn't press it, and then you are pressing it now, then it will change the state and it will set the button to 1. So you remember, now you previous state it was pressing it, and it will print out press. Then when there is a change in state again, or else if button is equivalent 1, that means previously you were pressing it, and now you are releasing it. Now you are releasing the button. Previously you was pressing it, now you are releasing it. It will auto change the state, you will remember it, and then it will update the status. So that is how this is done. You can actually refer to this. Next, okay, so forgot. Next, in second circuit, okay, the second circuit here, yeah, forgot second circuit, this number 2. So what it does is that when I start the simulation, okay, start the simulation. So what it does is that this button here, when I press once, because of the previous circuit, you already know how to remember the previous state of the button. So now when I press the button once, it will switch on the LED. When I press it again, it will switch off the LED. How is this done? This is actually a modification of the previous code. So if you are not pressing it, okay, you are not pressing it, and or maybe you are pressing it. I think this is pressing it. Yeah, this is pressing it, because this is a pull down resistor. This is done a different way. So if you press it, and previously you are not pressing it, then you said that you have pressed it. And if the previous state of the LED is low, okay, if previous state of the LED is low, it will set it to high. That means it switch on, okay, or else it will switch off. So this one is to do the changing of the LED, okay, or else you let it go, you let go the button, then it will just update the status. So when I press it down once, I keep pressing it, the LED doesn't change. It doesn't on and off. Okay, I let go, then it changes the button state. Okay, so we can also print out the button using the serial monitor. We actually print out what is actually done here if you want to. Okay, so this is just a sample of how you use one button to control an LED. Okay, you don't need to use a switch, okay, to actually control the LED. You don't need to have two buttons to actually do it. You can just use one button, and it remembers the previous state, and you can actually control the LED switching on or off. Okay, next. So other than catching repetition, controlling the LED switch, you can also think about using this as a counter. So what I mean by counter is when you press the button once, it add 1, okay, and you let go. When you press once again, it will add to the count. So it's a counter. So you can actually think of creating a counter by modifying the previous circuit. So you can actually modify this circuit and make it become a counter, okay, if you are able to do so. Okay, so some things that you can try and improve your programming skills. So another thing is button state. So if you put in two buttons, okay, you can actually use 4 methods. These are 4 methods that are same thing to actually print out the status of the two buttons. So you have two buttons that can only be 4 scenarios. Then the four scenarios are both are not pressed, both are pressed, or one of the button is pressed, 6 pressed, 7 pressed. Okay, so this is the first method of writing to how you can do the printing. The second method, so this is a if, and then there is a to statement. So you are checking that if 6 is not pressed and 7 is not pressed. And this is if 6 is pressed and 7 is pressed. And this is if 6 is pressed and 7 is not pressed, if 6 is not pressed and 7 is pressed. So it is one way of writing it using for if statement. Okay, for if statement. So every time it runs through the loop, it need to ask these 4 questions in order to determine what to print out. Okay, so the second method of doing it is to use if, or if else if. So if else if. So if it's not this state, then is it this state? Is it this scenario? If it's not this scenario, then is it this scenario? Okay, so this is the second method of writing the if else statement, okay, that you may want to try out. But it still prints out the 4 states. You can see from here the blue color blocks. Then the third one is this if else, and then after that, this one asks the nested if question. So you can actually see that there's a difference in the structure of all four of these programming method. Okay, so some of them are just asking one question. Okay, if 6 is pressed, then we ask the next question, if 7 is pressed. So if this pass through, that means both button is pressed, or else only 6 is pressed. Okay, so this is asking 2 questions separately. Okay, so you can actually refer to these to actually think about how you can actually use if else statements to be better at programming. Okay, so I guess that's it for today. So thank you very much.